Hello and welcome back to STEM Online Academy. Um, my name is Jason. It's been a while since I showed my face. I'm going to at least show my face at least once out of the total of 3 videos that I make per week about my brand, STEM Online. Okay, so let's get back to it. Um, the third video today is going to be interesting. We're going to get right to the bulk of why you guys have trouble and why you're freezing when it comes to calculus exams. Okay. And the reason why, right? Most students do not fail calculus. They don't fail hard calculus because they somehow, you know, because they're bad at math or whatever. They fail because they do not have a strong system for problem solving challenges. Okay. So we're going to have me here and I'm going to use the whiteboard at the same time. Okay. So give me a sec. All right. I want you to pay attention to the whiteboard right next to me. Okay. That way. It's funny in OBS Studio if any of you guys use that. All right. So here we go. Hopefully you can see the whiteboard. All right. And let's get right to it. Okay. So here's the truth why you're having trouble. It's because I too had trouble one time, right? One time I was not a good I wasn't a good student, right? I used to struggle with math, right? Until two teachers showed me a unique method uh to break down any hard problem into a system. Okay? So let me write that right over here, right? So here's my systems technique that I use. Okay, so the systems technique. Now, it's not the perfect formula to solve all of your problems, but it's very handy. Okay, so systems technique. Okay, hopefully you can see that. And the first thing you want to do for step one, okay, is you want to be able to visualize. Okay, you want to be able to visualize. That's step one. Step two is you want to then go to model. Okay. Step three, okay, you want to go to execute. So there's the execution phase. And finally moving to step four, verify. Because how are we going to be good at math if we don't verify things? That wouldn't make any sense. Okay. All right. So let's look at, right? Let's look at solving the following problem really fast. Okay. And for those of you who have watched my channels, you know my problems are really hard, but I'm just going to do a somewhat of a basic problem. Okay. Right, just to show you, to engage with you on a common problem that you will show up in your classes. So let's look at this problem right here, right? So let's say we want to take the limit. Okay, so let's say we take the limit. Take 1 second. Take the limit as x goes to 0. Okay, of what was the problem? Yeah, give me a sec. I had it here. I think it was sine x. Yeah, sine x minus x all over x cubed. Okay, if you look at this problem right here. Now, the way to solve this, right? The way to solve this is using the following. Okay, we are going to be looking at, right, something called L'Hopital, right? So a lot of you can relate to that. Okay, and L'Hopital is used when we have a function divided by another function. Taking the limit of a function divided by another function, making sure that it's not indeterminate. We have to check for indeterminacy, right? So in the denominator, you'll notice that this x cubed, if I plug in x goes to 0, I get indeterminate. right? So a lot of you are making the mistake and putting x equals 0 into your denominator. Don't do that. That's nonsense. Okay. What you have to do is do the following. Okay. Okay. So let's get my red marker here. Okay. All right. So what we're going to do is, right, is we're going to do this. Oh, we don't even have to use. No, we don't have to use L'Hopital's rule. My mistake. We're going to use Maclaurin. Okay. Let me explain. So I'm going to take the limit as x goes to 0. Sine x, the Maclaurin expansion for sine x is x minus x cubed over 6 plus right? So x minus x cubed over 6 plus dot, right? Minus x, right? All over x cubed, right? X cubed. Okay, does that make sense? I'm just using a Maclaurin expansion here. Okay, so if you do not know, right, for sine x, right, I'll just write down here, note, for those of you who don't know, note, I'm just using a Maclaurin expansion, right? That, put over here, use a better color. Yes, note that sine x is equal to x minus x cubed over 6 plus it's x minus x cubed over 6, 1, 2, 3, 5, plus x to the 5th over, I'm forgetting the next part here. Sorry about that. Dot, 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 dot. We'll just say minus dot, 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 and some value here, something factorial. 1 factorial, 3 factorial, so it would be like 5 factorial, I believe. I can't remember exactly. Yeah, 5 factorial. X minus x cubed over 6 plus x to the 5th over 5 factorial minus dot, 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 dot. That is the sine x. This is the definition of the Maclaurin expansion for sine x. Okay, so definition. This is by, say, definition DEFN, Maclaurin expansion, Maclaurin expansion. Okay, I'll just use DEFN here. Make that better. Just use black. All right. So we've got black. We use black ink. DEFN definition of Maclaurin expansion, right, for sine x. Okay, that's all I'm doing. I'm just substituting that in here. Might as well just put the x to the 5 here. Plus x to the 5 over 5 factorial minus dot, dot, dot. Okay. And the key thing here, right, is to notice that this limit, right, this limit here, what you want to do is you want to notice that sine x, right, sine x minus x, right, sine x minus x is just going to be x to the 6, right, x to the 3 over 6, all right, right? So this portion right over here, right, sine x minus x, right, sine x minus x is just going to be x to the 3 minus x to the 3 over 6 plus x to the 5, right? So this becomes, note, sine x in the numerator is just going to be, if I rearrange, right? Sine x minus x is approximately equal to minus x cubed over 6, right? Plus x to the 5, 5 factorial, right? Okay, and that's what you would put in the denominator, actually. So yeah, we don't need that, we don't want that. So our limit would just become this, right? Our limit's just limit as x goes to 0, right? Sine x minus x cubed, sine x minus x, sorry, that's just going to reduce to minus x cubed over 6 plus x to the 5 over 5 factorial divided by x cubed. Okay. All right. And then from here, right, you would use L'Hopital and start doing that, right? Actually, I want you guys to do that for homework. Try doing it for homework and tell me what you get. Should be getting like -1/6, I believe. -1/6 would be the answer for this limit. I've made it simpler by inputting the Maclaurin expansion first for sine x, and then from there use L'Hopital rule, right? Because we still have to use L'Hopital rule because we have an indeterminacy in the denominator here when x goes to 0. So, yep. And then from there, you will get -1/6. Okay. So this is a short video. As I said, again, hard calculus is not about just, memorizing mere formulas and, stuff like that. That doesn't help at all. It's about knowing what to look for, what to deduce, what to putting connections together. That's what it's about. Okay. So if you freeze on hard problems, right? Hard problems, hard midterm problems or hard exam problems, um, midterm questions, whatever. Uh, comment system, right? Please comment system in the chat below when I upload this video, and I'll make more problems using my visualize, model, execute, and verify systems technique. Okay. Before I get going, as I said, now on I'm going to be doing 3 times a week of my YouTube videos. Okay. I'm going to make extra time with you guys. 2 of those videos will be faceless, where I do rigorous problem solving, right? When it comes to hard calculus problems, right? Hard calculus problems, calculus-based physics problems, and the logic behind calculus, right? So analysis as well, right? So as I said, 3 times a week, 2 times a week. 2 of those days would be really hard, rigorous problem solving, and one day a week, right? I'm actually going to show up, me myself, talking slightly about what's going on about the brand, my systems technique, and looking at a standard problem like this that you will definitely see on an exam midterm. Okay. All right. There'll be links below for anything that you want. If you're looking for, still don't get my systems technique, you can look at the bottom of my PDF. There's a free PDF that has my systems-based technique. It's for free. Please download it. Okay. It's going to help you go through a problem-solving approach when it comes to solving problems, right? Also, my new book called Axioms is out, right? And it's excellent. It's excellent when it comes to, I designed it specifically, right? I just wrote it specifically for students who do not have the prerequisites for calculus, right? It's an introductory logic book. It's a hard logic book, let's be honest. But it's the proper prerequisites that you need, such that you understand airtight arguments when it comes to calculus and analysis, right? Because real calculus is analysis, and we're going to be doing analysis on this channel if you haven't already noticed. Okay, so get that book if you're not understanding the prerequisites. Solidify the prerequisites, right? Okay, and if you want more information about coaching, I'm also a coach, not just an author. I give, one-on-one personalized coaching when it comes to hard calculus problems. Okay, so reach out to me. Need help? Again, for those of you who are new, this is a bit about me and the type of problems that we will be looking at on this YouTube channel. Okay, so stay tuned. Things are about to get very interesting on this channel. Okay, we're going to be looking at a lot of interesting problems. Okay, so like and subscribe. Please like and subscribe. It helps the channel, right? So like and subscribe, and I will see you guys next week. Bye-bye.